Introducing IP Fabric Network Infrastructure Management Platform Engineering Edition, or NIMPEE. NIMPEE is distributed as a VM and can be deployed on the workstation or in the data center, depending on the use case or scalability requirements. Once the VM is running, NIMPEE's interface is available on the provided link, which can be accessed by any modern browser, including from a mobile device. The only requirement to start managing any global network infrastructure with NIMPEE is a set of network authentication credentials. A read-only privilege is fully sufficient. No other information is required, although seeds can be entered as needed or platform operating scope can be changed through advanced settings. Global network discovery is started with a single button. Panes provide information about NIMPEE's operation, such as this informational message that the platform is performing seedless discovery. Bandwidth can be controlled in real time through NIMPEE's hierarchical bidirectional shaper by selecting the desired maximum rate. NIMPEE leverages its network infrastructure intelligence to follow network paths through forwarding and protocol state tables, minimizing scanning to only cases when the information about the known network is not available on any known device. This enables to operate scaled networks with only modest amount of bandwidth. The rate also throttles compute resource utilization, which is only a single core with 4 gigs of RAM with this deployment. Even with just a single i5-2520M core, NIMPEE averages out to about 100 devices per minute in the slab with multi-site inter-AS VPN firewalled global network. After discovery, network analysis is performed by collecting snapshots of the network state and calculating all the state changes and properties. The analysis process is also started with a single button. The dashboard provides an overview of the network analysis results, such as the network composition, the aggregate score in performance capacity and risk categories, and the natural drill down to individual reports and then to the underlying issues that were impacting the business at the moment of the analysis. Business impact is calculated for each issue based on the amount of productivity lost and the number of users affected by the issue, and can be further drilled down to situational graph of the issue's location. The specific element causing the issues in this case is interface 10/0, which is affecting performance for 100 users, but there are a lot of other paths in the vicinity that have similar performance issues. Along with every path and every network element, NIMPEE calculates business impact score for every user of the network as well. We can take one of the most impacted users and drill down to the engineering level by performing a host lookup. There are 2 layer 3 edge entries suggesting multiple gateways and 1 layer 2 edge entry for the specific user. Clicking on the host link calculates active topology in milliseconds, and the same task can be performed through any browser on desktop and mobile alike, and through any client it is just as responsive. There are 2 gateways, R5 and R6, and R5 is active gateway for this host in VLAN 113. It is connected to switch AC7 and there is a closer path through switch AC8. However, it is blocked, likely because of the route placement at AC21. We can check spanning tree instance for VLAN 113 in the technology section. Topology is visualized with forwarding ports marked in green and blocked ports in red. Rearranging the graph into a tree with the switch connecting active gateway as the root of the tree, we can see that there are some significant path inefficiencies for hosts connected to some of the switches. The STP instances for VLAN 113 belongs to layer 2 failure domain with ID 3, and further look into STP stability shows non-zero active change in all instances of this STP domain. We can visualize the whole layer 2 failure domain to see if the different route placements were set up in an attempt to balance VLANs or reduce radius. Layer 2 failure domain diagram displays all contiguously connected spanning tree instances and their properties. If the route or port states are different for at least one of the involved STP instances, it is denoted in yellow. The stats for forwarding and blocked ports are denoted as well. Color coding of device icons help to narrow down the issue, with higher traffic share represented by darker colors. We can see that the route placement is inefficient from gateway path point of view, and we can decide to perform a change by moving the route closer to the edge switch connecting the gateway, specifically AC7. And set backup route to the leaf switch connecting secondary gateway. All of this information can be exported as CSV or image and can be used directly in change documentation, including performance issues as the business reasoning for the change, host information to determine business impact, layer 2 failure domain to represent the worst case scenario, and spanning tree instance topologies to denote specific change procedures and goals, and other parameters as pre and post change verification, all of which complies with ITIL requirements needed to pass the CAB. Since we are going to change spanning tree instances, we can check gateway setup for those instances as well. NIMPEE automatically calculates site boundaries, and from the performance report we can see that the host is located in site 8. Visualizing the site shows considerable topologies with the routers R5 and R6 being directly connected via interface Ethernet 00 and connected to the LAN via interfaces 5.0 and 6.0 respectively. Checking first hop redundancy protocol setup for the site number 8 shows that indeed R5 and R6 are running first hop redundancy protocol and that 100% of VIPs in this relationship are actively routed by R5. Looking at the network gateway redundancy for site 8, we can see that all of the networks with users have redundant gateways. We can also visualize the contiguous routing domain for the site, where we can see that the routing is properly redundant. The color coding denotes higher traffic share in darker colors, and from these colors we can clearly see traffic polarization to one side, but we'll leave that issue for another time. There are a number of equal cost next hops between R5 and R6, while we just saw from the site diagram that the only direct L2 link between R5 and R6 is through E00. The other next hops are discovered through LAN facing interface. Since we are going to perform a change affecting the whole layer 2 failure domain for this LAN, we can include this layer 3 cleanup in the change as well, without affecting any more users than we already do with this STP route change. Once you're ready to perform the change, you can double click on any device on the map and your favorite terminal client will connect to the device. You will need your admin privileges to perform the change. After the change, you can rerun the analysis to visually verify if the change was performed properly. And here we can see that I actually missed one of the passive interface commands. So refixing it and rerunning the analysis, now we can see that the routing is now looking cleaner. We can perform the spanning tree change in the same way. Logging into the device from the map, a chat window to save on typing, and checking that AC7 is root for VLAN 1, AC19 for VLANs 110 through 119 except 113, and AC21 for the VLAN 113. AC8 isn't root for any of the VLANs. This is the same information as on the map, so with NIMPEE these checks become redundant. We'll make AC7 the root bridge first, set worst priority on AC8, and reset the priority on AC19 and AC21. Checking by habit, but with NIMPEE I can check the whole topology with a single look. AC7 is the new route. Traffic flow is visible by the color gradient with all the paths leading to route, which is now utilized the most. Forwarding and blocked paths of all involved spanning tree instances are consistent, and the furthest paths, which are vertical lines here, are all blocked as expected. Checking active network path of the host, we can see it is now much shorter. Performance can also be verified via dashboard, and we can attach performance report to the change document or even the whole new network analysis report. This concludes an overview of some of the features and capabilities of the IP Fabric NIMPEE version 17.01, the first limited release. The platform is licensed per core at very affordable prices, and the license pays for itself in days or even hours by eliminating productivity bottlenecks, reducing risk, and empowering network managers and engineers with network infrastructure intelligence required to manage scaled networks. Contact us today to see if your company qualifies for limited free trial, or stay tuned for public release. For more information, visit ipfabric.io.